Everyone, so in a previous video I said we were going through some hard questions. Now I've just chosen some harder ones. I don't want this video to go for too long, so might do this in two parts. We'll see how we go. Alright, let's make a start. So Calvin puts 7,500 into an investment. So I'm going to highlight as we go along just to save a bit of time. Paying 4.7% per annum, compounding monthly. He makes regular additional contributions to the investment each month. After 1 year, Calvin's investment is worth this amount to the nearest cent. So he's made additional contributions, but we don't know how much that is. All right, and he's doing them monthly. So usually your payments and your compounding periods are the same length of time. So monthly for both of them. All right, for part A, find the amount of Calvin's regular monthly payment to the nearest cent. Let's get this calculator open. So we'll clear what we had before. All right, so we can put all this straight into the calculator, and that's probably the ideal situation. But if you're someone who gets a little bit confused, I would either write these down before putting it into the calculator, or prior to a SAC or an exam, I would actually have this template already in your bound book that you can just write into. So you've already got it there, you don't have to rewrite it. So some students are okay putting it straight into your calculator. Otherwise, I would have just screenshot what we've got here. I'll show you what I mean. So you could just go like this and have them already printed and stuck in your bound book. So then you can write them down. So you're kind of thinking about it. Sometimes it's better to think about it and then put it into your calculator. Obviously, to save time, it's probably good to just put it straight into your calculator. But it's better to take your time and get the answer correct than rush and not get it correct. All right. I'm just going to fill it in because I am in a rush. All right. So we're finding, all right, what are we doing? How long after 1 year? All right, so I had to find out N, and that's important information. So after 1 year, we know what that future value is. All right, so we're going to start off with N is 12. Our interest rate, remember, it's your annual interest rate, so it's 4.7. The principal value is how much the investment is. And remember, it's money going into the bank, so it's going to be negative 7,500. Payment is what we're going to work out, so we'll leave that one blank for now. Now he gets in return the $13,991.15, and it's positive because it comes back to him. Now your PY and your CY is 12 and 12, so we'll just, oops, come on, do them. All right, so PMT, there we go. So $500, and you'd probably want it to be like a number that's going to be an integer. So what I mean by that, it'd look a bit weird if Calvin every month put $267.32 into the bank. So $500 makes sense. Although you can have some weird amount, it doesn't really matter. All right, so part B, find the amount that Calvin invested in, actually, sorry, before we do that, remember 2 decimal places, so I'm not going to write it, but that should be your answer, $500.00. No negative, all right, so just 500.00. Find the amount that Calvin invested in the first year through monthly payments. So find the amount that Calvin invested in the first year through, all right, so he's invested $500. I might do this on the screen. So remember A was $500 and B, how much did he invest? So 12 years times 500 gives us $6,000. Find the increase in value of the investment in the first year. All right, so that was part 1, part 2. So the difference between the two, so 13,991.15 minus the 7,500. And I'm going to do that in the calculator because it's late in the day. brain's not working too well. 1.15 minus 7,500. 6491.15. Alright, so I might just tidy that up a bit. Get rid of that. Oh, excuse me. So that's how much it's increased by. So it's increased with that $6,000 that Calvin put in, but also the interest. So part 3 is actually wanting to calculate the interest, hence find how much interest was earned. So the difference between the amount he put in, the 6,000, and the amount it increased by. So just this value here minus this value, which I'm not going to write. I'm just going to do 491.15. Alright, given Calvin's monthly payment found in A, how many months will it take for Calvin's investment to be worth at least $20,000? So back on the calculator, going back to your financial solver. Come on. Alright, so we've got to keep it as it is, but we want the future value to be $20,000. Alright, and it says how many months. So we're calculating the n this time. Alright, so 22.6 blah blah blah. We've got to do whole months. So if it was 22 months, it's not going to quite be there. So it's going to be 23 months. Alrighty, moving along. Rahul borrows, let me just highlight. So this is a loan this time, $17,000 at an interest rate of 6.8% per annum compounding monthly. He wishes to pay off the reducing balance loan in 30 months. There's only one type of loan with compound interest, so that's reducing balance. It's all in your notes anyway. And I'm not going to refer to the notes. We've gone through them enough in the previous videos, but you should be using them as well. By making equal payments for 29 months followed by a final payment that is close to the regular payment as possible. Find the regular monthly payment. All right. So clear what we've got. All right, so N, let me just think, what are we doing? So N, I don't think we need to do 29 months. Let me just keep going. What have we got? 17,000. Let me do it as we read it. So borrows 17,000. All right, so he's borrowing money, so it's going to go in as positive. All right, interest rate is 6.8. Compounding monthly, so we're going to put 12 and 12 down the bottom. Probably easier, yeah, to fill it in as we go. Rahul wishes to pay off the reducing balance loan in 30 months. Now okay, we'll do 30. By making equal payments for 29 months followed by a final payment that is close to the regular payment as possible. Alright, so if he's paying 0, well, we want it to get to 0. So the payments, whoops, $617.80, so we'll round that to 80 cents. So it'd probably be 80 cents, but remember our final payment is going to be slightly different. So in part B, we've got to find that final payment of the loan. So if we just do, if we put in, 30 there, and we're going to change this to 617.80 cents. All right, so you're getting an extra, what is that, 8 cents. So you're going to be $617. Let me just write it down. All right, so the monthly payments we're going to do, $618.80. I think that was right. Let me just double check. 617. I knew it. I knew it as I wrote the 8 that it was going to be 7. All right, and then looking at my calculator, notice what's highlighted. All right, we've got that 8 cents remaining. So we're going to do $617.80 minus 8 cents. So our final payment is going to be $617.72. Find the total of the repayments of the loan. So is made 29 times 617. Oh, actually, what we can do, it's an easier way, sorry. 30 times 617.80, and then we can take away that 0.08 cents. So 30 months. So I'm just making sure, did I do, yeah, did it very quickly. I was just worried I didn't put the thing in properly. All right, 617.8 minus 0.08. So the total repayments was 18,533.92. Find the total amount of interest. So what we can do is we've got this amount is how, so you've got a loan, you're repaying that loan. So let's say we bought a car for $17,000 and I got a loan for $17,000. I would in fact repay this amount here. All right, so we're repaying that amount. So the difference between the 18,533 and the 17,000 is how much interest we're paying. So 18,533.92 minus the 17,000. All right, so we can just drag that down, minus 17,000. All right, so we've paid in interest $1,533.92. All right, moving along. So Oleg invests $100,000 into an annuity. Let me just highlight things as we go. So we're looking at an annuity with interest compounding monthly. What is the smallest interest rate that would allow Oleg, so we want the interest rate, to withdraw $2,500 each month for 4 years? Round your answer to 2 decimal places. All right, so we're going back to the financial. Most of these questions you're doing in Finance Solver. So that's why I think it's a good idea to screenshot this and then you can do it in your book before transferring it onto the calculator. All right, he's investing $100,000. It's going to work for me. All right, into an annuity, compounding monthly, so we'll put that in. So the 12 and the 12 down the bottom. What is the smallest interest rate? So that's what we're going to leave blank. To withdraw 2,000. Oh, what am I doing that there for? Sorry, that's our principal value. Silly, silly. All right. So it's an investment, so that's why it's negative, and payments coming back. So that's going to be positive. Each month for 4 years. So we've got 4 years and it's monthly. So if you knew it was 48, you could write 48 there, but you can also just write 4 times 12. And our future value, to withdraw, let me just quickly check. So we're assuming, what is the smallest interest rate that would allow Oleg to withdraw $2,500 each month for 4 years? All right, so 9.24. So I'm assuming Oleg's going to be withdrawing her 2,500. So, sorry. I really shouldn't do these videos when I'm very tired. Yeah, so withdrawing 2,500 for 48 months. and then getting down to $0. So to allow that to happen, because obviously he needs to earn interest as well, we've got that 9.24%. So everything is there. The future value, it didn't tell us, but we're assuming the whole money is gone. So we're going to have 0 there. So the smallest is 9.24%. Assume the interest rate is 6% and Alec wishes to be paid monthly payments for 4 years. How much will he receive each month as his regular payment? Assume that the final payment is as close. Okay, so we're just changing this interest amount to 6. And so what will he receive? There we go. So $2,348.50. So that remaining decimal places, that's where it's fixed at the end. So when it refers to the final payment, everything just changes, because obviously with cents we only go to 2 decimal places. Assume the interest rate is 6% and Alok receives a regular payment of $2,000 for how many months? All right, so we'll change that to 2,000. Remember, it's positive because he's getting the money, and this time we're solving for months. All right, so he'll get it for 57 months. He'll get the full payment, and then for the 58th month he'll get a smaller payment, basically. So 57 months, if you had to do that in years, you would just divide 57 by 12. All right, moving along. Kai invests $500,000 in an annuity. The annuity earns interest at the rate of 4.7% per annum, compounding monthly. The balance of Kai's annuity at the end of the first year, so end of the first year, so that's important, of the investment is this. Okay. What monthly payment did Kai receive? Just before we move on, just wanted to make sure that if you're using your notes, you should be looking at this page here, and just basically just this top part. All right, that's all you need to answer these questions. It's either going to be an investment, a loan, or an annuity. Okay, I know we had the difference between annuities and perpetuities. I think I've put some perpetuity questions in, which is fine. And then you've got your finance solver stuff there. But, you know, for your finance solver, it tells you whether it's positive or negative in this section. All right, getting back. All right, so on the calculator, we're going to go to clear page. All right, do things as we go. So it's an investment, so we're going to go to here. All right, so negative 500,000. The annuity earns interest at the rate of 4.7. Compounding monthly, so we need to put the 12 here and the 12 here. The balance of Kai's annuity at the end of the first year of the investment is that. So we're only investing it for 12 months. So your N is going to be 12, and your future value, put that number in, 474,965.28. Now it is positive because it's like if Kai wanted to, that money would come back to them. All right, and we've got to do the monthly payment. So they received $4,000 per month, which is quite nice, isn't it? Now, if we did this as negative, let me just show you the difference. Like you were unsure whether it was positive or negative. All right, you could, oh, whoops. No, that's right. I was just wondering whether I made a mistake. You can clearly see that you wouldn't be getting $81,000 a month. That doesn't make sense. So that's when you'd go, oh, maybe I should put a negative in here. So I'll go back to payment. There we go. That makes more sense. $4,000. Like imagine, like you're only putting in $500,000. So we're not like the Kardashians and probably getting $81,000. All right, so $4,000 sounds more realistic. So always question the, you know, the legitimacy of your answer. Did the $81,000 make sense? maybe if it was like $5 million, or maybe, I don't know, whatever, $10 million. All right, let's move on to question B. How much interest would Kai's annuity earn in the first year? Round your answer to the nearest cent. So what has happened is we've got a payment of $4,000. All right, we're going to round it to $4,000. So that means Kai has, from the annuity, received 4,000 times 12. What is that? I can do that in my head. All right, so received 48,000, and let's just have a look at the difference between our present value and our future value. All right, principal and our current value. So 500,000 minus 474,965.28. Whoops. All right, so we've got 25, so it's only gone down $25,000 because even though Kai has received 48,000, you've also got some interest. All right, we've got 4.7% per interest per annum. So let's look at the difference between 48,000, the amount Kai received, and the amount that the annuity went down by. So that means they received $22,965.28 in interest. All right, we'll keep going. And I've just realized this is page 13. There's 20 pages in this thing, so there will probably be 2 videos. All right, Samantha inherited $150,000 from her aunt. Oh, is that nice of her aunt? She decides to invest this money into an account paying 6.25% per annum, and it's compounding monthly. All right. If Samantha deposited her money in a perpetuity, what monthly payment would she receive? So let's go look at the notes just quickly. Just a quick recap of the difference between an annuity and a perpetuity. So looking at these couples up the top. So an annuity, you get an ongoing payment until the investment is $0. If it's a perpetuity, you get an ongoing payment forever. So it never, your principal value never goes, your value of your investment never goes below your principal value. So it's very important that we focus on this part here. So receives an ongoing payment, but the value of the investment never decreases. So in your calculator, your PV is the same as your FV. And we can have a look here. All right, so we've got the negative 150,000 and the future values are positive 150,000. All right, always the same. Let's put that into the calculator. All right, menu financial. Let's just clear the page. All right, so let's put in. She's inherited 150,000. It's a perpetuity is a type of annuity, which is a type of investment. So we're putting that money into the bank as a negative. All right, she decides to invest the money. Her interest rate is 6.25%. And it's compounding monthly, so we'll put 12, whoopsies, 12. All right, let's fill this in. So we want the future value to also be 150,000. And it's saying what monthly payment. So what we can do is you can put in just 1 month. All right, we just want to know what it is for 1 month. So we can just do n equals 1. And there's your payment. So Samantha will receive $781.25 each month. So basically that's the same as the interest. So 6.25% of 150,000. So you could have done 6.25 divided by 100 to turn it into a decimal, and then multiply that by your perpetuity amount. and I did annual. Let's just divide that by 12. I should have done. And I've got so many divide. So let's put that in brackets. All right, there we go. That's a bit easier. All right, let me just do that again because that looks a bit messy. So I'll put it as a fraction here. All right, so we've got our annual interest rate, if you're wondering what I just did, and we divided it by 12 because it's, we're looking at per month is your compounding periods. All right, I did yearly before, silly Billy. All right, and we're dividing it by 100 to change that amount. Because it's a percentage currently, 6.25%, we need to divide it to get it into a decimal. Can't think of the word. All right, and then we multiply that by our value of the perpetuity. All right, $781.25. So you could calculate it either way. If Samantha deposited her money into an annuity and withdrew $1,000 per month, so this time we're looking at an annuity, and she's withdrawing $1,000 per month, how much would she have in the account after 1 year? So let's go back to the financial solver. We'll keep what we've got in there because some things are the same. So it's still 6.25%. I'm just going to get rid of stuff that we're going to have to change. Still invested $150,000. She's now receiving a payment of $1,000, and we want to know the future value after 1 year. So N is going to be 12. Just get that working. All right, so that's how much she would have. So $147,298.48. So you can see it's gone down because the perpetuity amount was $781 or something. So if anything over that amount, obviously is going to decrease that $150,000. If Samantha deposited her money into an annuity and withdrew $4,000 for each month until the final month, how many regular payments of $4,000 would she receive? So let's just change this to a 4. All right, so let me just make sure I'm doing that right. Oh, hold on. I skipped to D. Let's do C. Oh my gosh. Sorry, guys. If Samantha deposited her money into an annuity and withdrew... Did I skip a question? All right. I think I combined B and C. Maybe. Oh my gosh. Did I? I can't even go back and let's change that to a 1. All right. Yes, I did do a 1. All right. Question C. This time her annuity is $2,000. Doing the right question. After how many months will the investment first be below $100,000? So let's put the $100,000 in here, our future value, and we just want to calculate N. So it makes sense because, you know, from probably even primary school when you're doing rounding, you're used to rounding that to 37. Now, if it was 37, it wouldn't be below 100,000, so we do need to round it to 38. So think about the context of the problem. If we had just 37, so if I just left that as 37, my future value will still be greater than 100,000. So I do need to change that to 38, and then we're below. Okay, so just make sure, and you can check it like I've just checked it then if you're unsure about which way to round, but we're doing whole numbers here, so months, so it does have to be 38 months for it to get below $100,000. All right, question D. If Samantha deposited her money into an annuity and withdrew $4,000 per month, so let's change it to a 4, okay. For each month until the final month, how many regular payments would she receive? So I need to change that to 0, and she would receive 42 payments. She would receive 41 payments of $4,000, and her final payment would be slightly different. So that's what question D part 2 is. What would be the value of her last withdrawal? So obviously we need to do 42. because 41, she's still going to have some money in there. So we're going to do 42. Do your future value. So it would be 4,000 minus that amount. Now what I'm going to do, because I have terrible memory, especially this late in the day, so I'm going to copy that amount. Hopefully it's worked for me. And go back onto my main screen, and I'm going to paste it in. Hopefully it's going to work. Sometimes, there we go, beautiful, worked for me. All right, so her last withdrawal would be $3,323.07. Make sure you round correctly. If you're ever unsure with rounding, do write more decimal places than required and then do your rounding. All right, I'm going to leave the video there. We've got plenty more questions to do, and I might do them in a separate, well, I will do them in a separate video. Bye guys.